Hello guys, welcome to Quality and Welding Metallurgy. I am Kalidas Tapada. Today we are discussing on welding process for chromium nickel austenitic stainless steel piping and tubing. Content of this chapter: shielded metal arc welding SMAW, gas tungsten arc welding GTAW, gas metal arc welding GMAW, submerged arc welding SAW, other welding process, welding of dissimilar stainless steel joint. Welding process: shielded metal arc and gas tungsten arc, the process most commonly used to weld stainless steel piping. Gas metal arc also used, but to a lesser extent. Submerged arc welding, although used in this application. Complete detail of this process will discuss in another chapter. Shielded metal arc welding SMAW or MMAW, manual metal arc welding of shielded metal arc welding of austenitic stainless steel piping and tubing may be performed with either DC or AC welding power source and cover electrode suitable for use corresponding for axial power source. Weld quality acceptable pressure piping service may be made with either AC or DC power, but each exhibits certain inherent advantage and problem. Working condition will have some influence on the type of welding equipment selected and therefore the type of welding electrode used. In isolated field application where an electric power line is not available, it is necessary to utilize portable welding units operated an internal combustion engine driving generator. Direct current power is almost exclusively used for field welding. In shop works where our electric power line is available, a welder choice of welding equipment is possible. There are three principal types of welding units: the electric motor generator, the gasoline or diesel engine drive generator rectifier. The shielded metal arc welding process is often used for welding stainless steel piping. However, the welding of thin walled, small diameter pipe is difficult with this process. The problem encountered are associated with the maintained proper current density and provide satisfactory metal transfer, yet avoid overheating and creating hole. Gas tungsten arc welding GTAW or TIG welding. In this welding process, as an arc is maintained between a tungsten electrode and the workpiece, a sheet of shielding gas, either helium or argon, or a mixture of two, is projected around the arc. Flux are not necessary when welding with this process because flux are not available to remove impurity. Special precaution must be taken to assure the surface cleanness of the base metal and filler metal. Wind and draft must be avoided because of the disturbed the gas shield. The use of direct current electrode negative is necessary when GTAW stainless steel pipe. Argon gas, argon shielded gas is used most application for equal arc length and welding current. This tungsten or voltage in helium will be about 50% higher than the tungsten arc voltage in argon. While this while this permit more uniform joint penetration and higher welding speed, it also limits the use of the combination of thick section. On this section, on thin section, it has been found that the colder arc in argon assists in avoiding excessive root penetration. The division between thin and thicker section is about 14 gauge Birmingham wire gauge 0.074 inch 1.888 mm. Thin wall stainless steel pipe schedule 5 in some case schedule 10 may be welded without addition of filler metal simply by fusing the edge together. On thick walled pipe, filler metal for the root pass may be provided by the use of consumable insert. Subsequent filler metal may be introduced by manual or machine filling. The gas tungsten arc welding process used extensively for welding the root pass in pipe of heavier wall thickness with subsequent passes made by SMAW, SAW or GTAW. Heated filler metal should be protected by shielding gas to prevent oxidation. The root side of the weld should also be protected by the suitable shielding gas. A distinctive feature of the gas tungsten arc welding process is its ability to transfer filler metal to the weld with minimum loss of alloying element. One problem associated with this process is tungsten contamination of the weld metal. This condition occurs when the end of the tungsten electrode is inadvertently dipped into the weld pool and could occur when the arc is started without benefit of the high frequency equipment. Gas tungsten arc welding is suitable at any thickness of the pipe. It is most advantageous on thin weld section such as Schedule 5 and 10 and for root pass thick walled pipe. Gas metal arc welding MIG, GMA or MIG. In this process, the arc is maintained between the workpiece and filler metal in wire form, fed from a spool or reel. Shielded gas is projected around the arc. The primary gas shielded is a monatomic inert gas such as helium or argon. The primary shielding gas may be supplemented with active gas addition such as oxygen or carbon dioxide. Complete equipment include a gun that provide means for supplying welding power to the filler metal and conducting shielding gas to the arc. The process may be either semi-automated or automated. In the higher energy mode, it is characterized it is characterized high welding speed and high deposition rate and is essentially limited to the flat and horizontal position. In the low energy mode, short circuiting type of metal transfer, it is readily utilized for vertical, overhead and horizontal welding position and especially for thin walled pipe. Power for welding stainless steel is generally direct current electrode positive, although direct current electrode negative and even alternative current can be used with more special made electrode. Either helium or argon may be used as a shielding gas depending on the specific arc characteristics required for certain job conditions. Spatter is higher with helium. Helium may be added to argon up to 70% helium and 25% argon to control joint penetration and bed counter. Oxygen up to 5% may also be added to the helium argon or helium argon mixture to stabilize the arc and reduce undercut. For welding with short circuiting type of metal transfer, argon plus carbon dioxide up to 25% CO2 may be used. Oxygen may be substituted for part of the carbon dioxide. A mixture that has given very satisfactory result in 90% helium, 7.5% argon and 2.5% carbon dioxide. Pure carbon dioxide is not suitable as a shielded gas for the stainless steel. Welding of the large diameter pipe may be accomplished in all of the pipe welding position. The smaller diameter below 6 inch, 152.4 mm pipe size are difficult to weld in the fixed pipe welding position. The gas metal arc welding process retains the composition of the filler metal in the weld metal. Mechanical property of the weldment with the process are comparable to those obtained with the other process. Submerged arc welding SAW. In this process, an arc is maintained between the bare electrode and the workpiece. Multiple arcs are sometimes used. The welding arc is suitable by blanket of the granular flux. The normal function of the submerged arc flux to shield it and stabilize the arc protection, the weld metal and control bed counter. However, stainless steel weld metal are now frequently required to meet rather narrow range of the chemical composition and delta ferrite. The adequate satisfactory requirement in this area as well as perform its other function. This flux must be carefully formulated and reinforced with metallic compound to offset loss of elements such as chromium, niobium or Cb, manganese, etc. that occur during transfer the arc. When special critical control of well metal composition and delta ferrite is required, specific lot of flux is often formulated to be used with specific heat of electrode wire. When used natural, no metallic compound flux is specified, and close control of well metal composition and delta ferrite required for the composition of electrode wire must be high alloy content to compensate for loss of element across the arc. The submerged arc welding process usually characterized by high yielding current and relatively deep joint penetration. When this process is used on stainless steel pipe, the current is usually lower than the current used on ferritic steel. Welding power source. Welding power may be AC or DC. This process is limited to the flat or horizontal rolled position. The other welding process. Other welding process, because of the high chromium content of austenitic stainless steel and the affinity of the elements for carbon and oxygen. The austenitic stainless steel required good protection from carbonization and oxidization during welding. The latter requirement procedure the use of unshielded process for critical work. If the oxyacetylene process is used in natural flame is mandatory. Welding of dissimilar stainless steel joint. The selection of filler metal for welding various dissimilar austenitic stainless steel, where both the dissimilar stainless steel are either stabilized or have a low carbon content. The filler metal must also be stabilized or low carbon content. When stabilized or low carbon stainless steel is to be joined to another austenitic stainless steel that is not stabilized or does not have a low carbon content, it is satisfactory to select the filler metal that is not stabilized or does not have a low carbon content. For example, if type 347 were to be joined to type 304 stainless steel, type 308 filler metal may be used. Nothing would be gained by using type 347 filler metal because one half of the joint is stabilized. Most austenitic stainless steel have yearly equivalent coefficient thermal expansion so that the differential thermal expansion is not problem. In all cases, where dissimilar stainless steel joints are to be subjected to severe operating conditions. The joint should be thoroughly analyzed to assure the safe operation. Thank you.